Hello everyone. In this video, I will teach you how to use Python list comprehensions. That is, I will teach you how to write elegant and optimized Python code. What you can see over here is a post that I created that nicely summarizes everything that I will explain in this video. A link to this post is given in the description below. Besides this post, I will also explain the codes that you can see over here. First, let us explain the need for using list comprehensions. For example, I have the following problem. I have a list of numbers 1, 2, 3, 4, 5 until 11, and my assignment is to write a code that will compute the squares of these numbers. That is, the result should be 1, 4, 9, 16, 25, until 11 squared, that gives 121. Now, if you took a C class or C++ class or any type of class that covers some basic programming, you can easily solve this problem by writing a for loop. However, this approach is a non-Pythonic approach for solving this problem. There is a much more elegant approach for tackling this problem, and this problem can easily be tackled by using list comprehension. Basically, you can write a single code line that will solve this problem. So let's see how to solve this problem. Let us go back to our code, to our Python code. Okay, so first I will import numpy as np. Then I will define an empty list. So this list will store these numbers, the results. It will store 1, 4, 9, 16, 25 until 121. Okay, so I will write a for loop that will iterate I, index I, from 1 until 11. This is an iterator, range 12. It means that you're iterating until 11. And inside of this for loop, I will just append the elements of this list with the squares of the numbers. So this method .append will just add values to this list as they're being computed. So let's see what will happen. Here is our results. Here's our result. We have 0, 1, 4, 9, 16, 25 until 121. So this is a standard C type of approach, and this is non-Pythonic approach. Okay, here is another idea. We can use the map function, and we can define a function that will simply return the square of the number. So first I will define my numbers as a numpy array. So here's my array. Here it is. And then I define a function that will just square x and return the square of x. And then I will call this nice function map. I will provide the first argument. The first argument will be the function we defined, and the second argument will be an array. So what happens here? Basically, this function maps elements of the array numbers to this function. So this map will call the function take square for every element of the vector of an array numbers. And let's see how this code works. Okay, now if you basically evaluate this term, you see it's a map. You don't see immediately a list. So you need to convert this to the list, the squared numbers, by calling the list function. And let's see our list. Okay, so here is the result. Again, this might be a relatively more Pythonic way of solving this problem, but still, this is still too cumbersome approach for solving the problem. Can we solve this problem in a more compressed and more elegant form? Yes, we can. So let's see how to do that. I just need a single line of code to solve this problem. So what you can see over here is a basic usage of list comprehensions. What do I do here? Basically, I say that my list will consist of the square of number x for x in range 12. This means that I will take every x belonging to this iterator that goes from 1 to 11, and I'm going to square it, and I will form a list. So this 4x in range 12 means that I have an expression that will be evaluated and the list will be completed for some member in some iterable. Okay, so let's see how this code works. Okay, so here's our list. We get the result. Okay, here's another way. Here, instead of x squared, I can call a function. So basically, I can call the function take square x for x in numbers. Okay, where numbers is defined over here, and I will get the same result. Okay, so you see the power of comprehensions, of list comprehensions. So you can place an expression and evaluate this expression for all the members x inside of some array or belonging to some iterator or etc. Let's go further. Let me illustrate you the true power of list comprehensions. So let's see what happens over here. Let's say I have a sentence. My name is John Doe. I'm here to help you. Please ask me a question. And let me define another string that consists of vowels of A, E, I, O, U. And I want somehow to track the vowels or to count them inside of this string. So what do? I simply say vowel list. I say x. That is, I'm going to collect x in my list for x in sentence. Here the sentence is considered as a list, or better to say an array of characters. That's basically a string. And I'm going to only include x if my x is an entry of this string of vowels. Let's see this. Let's see what happens. And here's my vowel list. Here's my A. Basically, this A is this one. Then I have E. Here's my E. Then I have I. Here's my I. Then next one is O, etc. Here are other vowels, and I can track these vowels. Okay, you see the true power of list comprehensions. So, very complex code can be compressed, and you can express this code by using a single code line. This is a very elegant approach that simplifies complex codes. Let us see other applications of list comprehensions. Let us assume that you have a list of numbers. I have 5, minus 1.5, 7, 0, 2, and minus 1. And I want to define a function, or I want to define some code or procedure that will replace all negative values by zeros. So basically my output should be 5, 0, 7, 0, 2, 0. How to do that? Well, you can use list comprehensions. I will say x, include x, if x is larger than 0, or, oh no, here you're including x if x is larger than 0. If that's not the case, then you basically return 0 for x in these numbers. So the general expression is the expression, then you can add if conditional for member in iterable. So let's see what happens. Here's my result. 507020. Now, let us say that we don't want zeros, we want simply to eliminate zeros. Then you will add if statements at the end of the list comprehensions. I will say x for x in list of numbers only if x is larger than 0. That is, I'm going to include x only my x is larger than 0. Okay, so here you have seen the true power of list comprehensions. Over here again, you can see the code that I wrote and that explains list comprehensions in more details. Okay, that would be all for today. I hope that you like this video. If you like the videos I make, please subscribe to my channel or support my channel in some other way. Thank you very much and have a nice day.